All right, let's jump right into this explainer. Today, we're going to use a bit of a stop motion building block approach to really demystify how complex software systems are designed and, crucially, how they scale. If you've ever sat there wondering how these massive tech giants keep their platforms running without totally collapsing under the pressure, well, it all comes down to the foundational blocks they choose.
Here's our instruction manual for today. We're going to cover the architecture blueprint, traditional layered builds, microservices and distributed systems, event-driven and space-based setups, the clean architecture core, and finally, choosing your architecture.
Okay, Section 1, the architecture blueprint. So here's the crucial thing to remember. Architecture patterns dictate the high-level structural organization of our entire system. While a design pattern might help you code a very specific function, an architecture pattern is your macro-level blueprint. Without it, you are completely vulnerable to creating what developers literally dread the most: a disorganized, tangled, big ball of mud where every single thing depends on everything else. Think of every software system as a massive Lego set. The exact way you snap these blocks together completely changes the agility, the scalability, and the performance of your final build. You can't just throw pieces into a random pile, right? You need a deliberate strategy to make sure the final structure doesn't just topple over the second a million users try to interact with it. Moving on to Section 2, traditional layered builds. Notice how each block layer here is neatly stacked on top of the next. This is your classic traditional layered architecture. The flow here is strictly top-down. Requests come in through the presentation layer, travel down through business and persistence, and eventually hit the database layer. Because each layer has a highly specific job, the presentation layer never has to worry about complex database logic. It's totally organized and completely separated by concern. Now, while this multi-story block tower is pretty much the standard and it's incredibly cost-effective to get off the ground, it definitely has its limitations. Its rigid top-to-bottom dependencies basically make it a monolithic structure. And because business logic tends to get dispersed across technical layers rather than grouped by actual business features, which makes domain-driven design super difficult, by the way, it can be incredibly hard to scale this thing horizontally when traffic suddenly spikes. So that leads us to the million-dollar question. What happens when a system gets too big for a single block? When a layered monolith just can't handle the high traffic, or honestly, when your dev team gets way too large to work on a single code base without stepping all over each other's toes, well, we have to start breaking our giant block apart into smaller, distributed pieces. Which brings us to Section 3, microservices and distributed systems. Instead of building one giant, fragile tower, microservices are a lot like a neighborhood of separate, tiny blockhouses that communicate with each other over a network. Each individual service is completely self-contained. Actually, to truly decouple them, each service typically gets its very own dedicated database. What this means for us is that you can update, scale, or literally rewrite one small component without bringing down the rest of the entire application. Pretty cool, right? But microservices come with some major built-in trade-offs. Yes, they give you amazing fault isolation, so if one service crashes, the rest of the neighborhood stays up, and you get highly granular scaling. But man, you pay a steep price in complexity. You're basically trading easier code management for massive deployment and infrastructure headaches. And don't even get me started on the incredibly complex integration testing you'll have to do. Let's look at Section 4, event-driven and space-based architectures. Here we have two distinct powerhouses when it comes to massive scale. Event-driven blocks instantly react to triggers, kind of like dominoes falling asynchronously. The system emits an event, and any interested component just consumes it and reacts. Then, space-based architecture takes a totally different approach. It uses shared memory, basically temporarily storing data in the system's active RAM instead of a hard drive, to completely eliminate the central database as a single point of failure. It is absolutely perfect for those unpredictable, massive traffic spikes where a traditional database would just straight up crash. Because event-driven architecture allows these independent, decoupled components to react to events the exact millisecond they happen, it's really the invisible engine behind today's most highly responsive systems. We're talking the lightning-fast reactions needed in algorithmic stock trading, continuous data streams in multiplayer online gaming, IoT sensors. EDA ensures the whole system reacts dynamically without getting bogged down by sequential processing. All right, Section 5, the clean architecture core. So the really crucial takeaway from this fantastic Zen engineering article is that despite all the different shapes and names, whether you call it clean, onion, or hexagonal, these three patterns actually solve the exact same fundamental problem. They exist for one reason: to prevent massive, painful application rewrites when you inevitably have to replace external elements like your underlying database or your UI framework. The hexagonal, or ports and adapters, model shows exactly how this works in practice. Look right at the center there. You build a pure domain kernel that contains all your vital business logic. And this core? It depends on absolutely nothing outside of itself. Then you just snap on your external databases, user interfaces, or third-party APIs exactly like interchangeable plugin blocks. Need to swap MySQL for PostgreSQL? No problem. You just swap the adapter block. The core remains completely untouched. It's a real game changer.
Finally, Section 6, Choosing Your Architecture.
You know, the old no free lunch rule of software architecture means every single choice has a cost. The layered architecture excels in simplicity and testability, but it really suffers when it comes to scalability. Conversely, if your main priority is ultimate scalability and performance, you absolutely must pivot to event-driven or space-based blocks, but you'll be sacrificing simplicity in development and testing to get there. Even niche options, like a microkernel setup, offer great agility but come with their own distinct set of complexities.
To successfully navigate all these trade-offs, architects rely on what we call architectural drivers. And these aren't just vague, hand-wavy ideas. They are the absolute hard rules that determine which blocks your specific project actually needs. They encompass everything from your functional requirements, what the software is actually supposed to do, to strict technical constraints like your budget, your team's skills, and non-negotiable quality attributes like top-tier security or high availability. A great blog post from Salenza offers this incredibly practical 6-step approach. By methodically following these steps, you force yourself to align your architecture with reality. You identify those drivers, you honestly evaluate the trade-offs, and crucially, you assess your actual team resources. If your team doesn't have the DevOps skills to manage microservices, you need to identify that risk early. This data-driven approach makes sure you're picking the architecture pattern that practically guarantees long-term stability for your exact context. So, as we wrap up this explainer, I want you to take a hard, objective look at the blueprint of your current project. Are you maybe using a monolith when you desperately need the scale of microservices? Or, on the flip side, are you drowning in the complexity of microservices when a layered approach would have been totally fine? Based on your unique drivers, ask yourself, are you truly snapping together the right blocks to serve your ultimate goals? Thanks for joining me on this deep dive, and keep building smart.